Okey-doke, we'll go ahead and get started. Lou, will you just watch the channel to see if any other people join and share the link in case they miss it in the chat if they want to follow along. So today we're going to talk about upgrading PostgreSQL versions with minimal downtime. I'm Corey O'Daniel, one of the co-founders and CEO of MassDriver. MassDriver is a visual development environment for managing cloud infrastructure. During the webinar, a couple of my coworkers will be in the chat and the Q&A rooms answering any questions, and then we'll hang on the call afterwards for additional questions. Okie doke, so let's go ahead and get going. Again, the source code is on GitHub if you do want to follow along or want to try it out later. What we're going to discuss today is different tools for upgrading PostgreSQL. There are a number of them. We'll talk about the two different methods of using logical replication, which is how we'll be doing the upgrade today. We'll also discuss the write-ahead log and log sequence numbers of Postgres. Both of these are pretty key to understanding how replication works and also just how the underlying storage of Postgres works. And then at the end, we'll do a database promotion. So we'll cut over from our Postgres 12 to our Postgres 15 instance. We'll end the call with a brief demo of how you can manage Aurora instances in MassDriver. So there are four primary ways of upgrading Postgres databases. Yeah, there's four. There's probably many more, but these are the ones that everybody uses. So the first one is dump and restore, and this is one that's pretty interesting. So what's interesting with dump and restore is I think that a lot of times engineers can feel like the uptime of their application needs to be higher than what the business may see. So I generally like to talk to my business partners when I'm doing a major version upgrade to discuss, can we take downtime and just do a dump and restore versus spending a lot of engineering effort to do an online migration. So I think that that's one of the things that's really key in planning these migrations is making sure the business understands the amount of time and effort to not have downtime. So the PG dump and restore does work for doing major version upgrades. You'll need to make sure that PG dump is the version of Postgres that you're going to be migrating to. The second option is PG upgrade. This is a binary built by the Postgres team. It's really great for small databases. It'll upgrade your instance in place. You will experience an outage during the upgrade, so no reads or writes are possible during the upgrade process. There's been some tests that I've seen where people have been able to upgrade multiple terabytes of data in a couple of minutes. So it's really good for doing a migration pretty quickly. What I'll generally recommend if you're using PG upgrade though, because you have that brief outage, and you're also putting all your eggs in one basket, is I would actually suggest doing it in a primary replica scenario. So having a primary database, Postgres 12, a replica that's also Postgres 12, and doing the upgrade on your replica and then failing over so you have a fallback. If you just do PG upgrade in place, you don't have a fallback database. The third that's pretty common is Bocardo. So this is a really great tool for doing multi-primaries in Postgres or primary replica replication. It can also do version upgrades. It has a steeper learning curve than logical replication, and it will generally require that you have an additional compute node or VM to run it on. And then finally, logical replication, which is what we're going to get into here. This is a really great feature of Postgres. So it's not an additional tool, it's an additional binary. It's built into Postgres. It's a really great feature to be aware of. It can do version upgrades, but it can also do instance migrations. Maybe you're running on Heroku Postgres and you want to move to AWS Aurora. You can use logical replication to actually migrate your instances as well. You can use logical replication at the database level or at the table level. So it's really good also if you're doing data warehousing, ETL, change data capture, you can use logical replication to send these records straight out from your database into maybe a Lambda or some other ETL system. So I saw a few more people come in. I just want to note that there is a link to GitHub in the chat that has a README walking through this webinar. If you do want to follow along or if you want to walk through it later. And there's also a Docker Compose file that has Postgres 12 and 15 that we're going to be using to do the demonstration today. Okay, so what is logical replication? So this is a data synchronization method that enables replication of individual database changes, DML, inserts, updates, and deletes, in a fine-grained manner between two Postgres databases. It uses a pub/sub model. So changes to your source database are captured. They're transformed through this process called logical decoding, put on the network and then applied to a target database. So one of the key things with logical replication, though, is it does not, there's a number of things that it does not replicate. It does not replicate DDL, so data definition language, how you're creating your tables or altering your columns. Your databases have to have the same schema in place. So when you're doing one of these migrations, it's really best to avoid any sort of logical database migrations of actually changing how your tables are structured or adding tables while the migration is happening. It also doesn't copy sequence data. So if you're using auto incrementing numbers on your tables, those sequences aren't copied over, which could mean you have conflicting primary keys, which isn't great. So we'll walk through at the end during the promotion process to show how to synchronize those sequences as well. And it also does not refresh any materialized views. That's another thing you'll have to do in kind of post-migration is refresh those views. So this is logical replication in action. We have a source database here on the left, the target database on the right. The source database has created a publication. The target database will create a subscription and subscribe to that. So the way that this works internally to the database is commits are written to Postgres. When those commits happen, they get written to two places. One to the wall, the write-ahead log, which we'll dive into a bit more here in a second, and one to disk, so the actual data files. When you're doing logical replication, there's two processes that run on your source database, the wall sender and the logical decoder. The wall sender is constantly pulling off new wall entries and distributing them to all of your subscriptions. The logical decoder actually is kind of like a transform that can be applied to the data. So you'll generally use one called PG output, which is Postgres's native format, but you can also do one called wall to JSON, for example, and it will convert your wall data to JSON, which is really great because you can now send this to, let's say, a Lambda if you want to do some ETL. On the target database side, very similar to the commit process, you have this subscription worker. It's receiving these wall items, it's writing it to the subscription database's own wall and to data as well. So it's really interesting. You can actually do chains of replication here. Now, the write-ahead log, we mentioned this a couple of times here. The write-ahead log is a transactional log that records all the changes in a sequential manner to Postgres. So you can kind of think of it like event sourcing. It is a list of changes that if you apply it to the database in the same order, will give you the same data set. So that's one of the key terms that we'll hear a lot as we're going through this migration. The other one is LSN, or log sequence numbers. So we'll be looking at these a lot as we're going through the migration process. These are unique identifiers that track and manage the order of the wall. So this is like a whole other talk in and of itself. If you're not familiar with log sequence numbers, this is the first time you're hearing about it. This is a really interesting data structure for storing information about the wall. So you can actually take two of these log sequence numbers. They look very bizarre when we see them here in a minute, but you can take two of them and it'll tell you how many bytes apart your Postgres primary and replicas are. So this is a number that we'll kind of watch to be able to tell how in sync we are. Okay, and again, there is a link in the chat if you do want to follow along. There's a README and a Docker Compose file there that you can use to bring up the demo if you want to just kind of copy and paste commands and follow along with me. So what we'll see when if you hop over to that README is there's actually two ways of doing logical replication. And we'll talk about those in depth here in just a second. But when you're going through the logical replication process, the way that we're going to be doing it, it's about 8 steps to get the database migrated. So the first one will be stopping your applications, putting them in maintenance mode. You'll be taking a dump of your application, creating the publications and replication slots, and then you'll restart the app. So that's effectively the window of downtime that you have there. What's really cool is Postgres 15 isn't even in the equation yet. So you've had this downtime and you're ready to bring up as many other replicas as you want at this point in time. We'll restore a snapshot to Postgres 15. We'll create the subscription. So it has a bunch of old data, create the subscription. Now it's ready to get the new data. At this point in time, we can add a bunch of records, and we'll do this in the demo, to the Postgres 12 database. You can see that they'll be out of sync. And then as soon as you turn on that subscription, you'll see the data start to replicate across and the databases get synchronized. So as I mentioned, there's 2 different ways of doing logical replication. And so it really kind of depends on what your database size is and the size of your database and where your 2 databases are. So when we set up this subscription, you're going to see that there's a property called copy data. And so when you're doing a logical replication, the subscription can actually say, hey, start from the beginning of time. So if you have a small database and you say copy data true, great. Like it is the easiest way to do logical replication. Couple of commands and you're ready to go. So we actually have this as one of the options in the README. It's about 3 commands and boom, your databases are in sync. Now, if you are doing a migration from Heroku to AWS and you're traversing public internet, multiple networks, and you've got terabytes or petabytes of data, starting from the beginning of time can take a very long time. This isn't a PG dump where you've got this compressed data. It's literally change by change. And so if you have petabytes of data and millions or billions of transactions that have been written, those are going to be going across one at a time. So it can take a long time to get in sync when you do copy data true. And so what we're going to do today is copy data false. We're going to say, hey, we're bringing up this subscription. We don't want any data from the beginning of time. We're just going to start right now. So the really cool thing with this is there's no lag. You immediately start getting new records. The bad thing is you don't have any of the old data. So we need that to make the business side happy. So we'll talk about how to get this data in place so that you have all the data on your replica. So before we get started, what I want to do is just show everyone kind of how I have this set up locally. I have this Docker compose file running. If you are following along, you'll see that this Docker compose file in the repo, there's just 3 services in here. There is Postgres 12, which is where my data is written. There's Postgres 15, which is sitting idle. There's no database created on this instance yet. And then there is a Spree e-commerce application, which I also have running here. So you can see I've got a number of products, and I can even maybe add a new product. Let's add cat hats. Cats notoriously get cold heads. You might need a cat hat, so we're going to add that to the database. So this just added an additional record to my Postgres 12 database. So I've got this application running. This is what we're going to use to demo the transition. What I also have is 2 other tabs open. One is a shell and pSQL session to my Postgres 12 database. There's going to be a number of commands that we're going to run here. You can see that I have 118 products in this database. And then over here, this is my Postgres 15 database. If I try to look at my store, you'll see that there isn't a store database here yet. So this is all fine and dandy. Now, one of the things we have to do to be able to even start logical replication is set Postgres to allow logical replication, which isn't on by default. So if you are following along in the tutorial, you'll see that there's a PostgreSQL configuration file there. That's the default PostgreSQL configuration file that ships with Docker with 2 additional edits. It turns on logical replication and sets a number of subscribers that it will be able to use. What I'm going to go ahead and do is just run a command real quick to get both my Postgres 12 and Postgres 15 instances configured for logical replication. And you should see that I got disconnected from both of these. Looks like they are both back up though. And now I am good to go. I've got logical replication enabled. So we're going to go ahead and connect these 2 instances across the pub sub mechanism here in just a second. Now, one more thing that's really important is logical replication only works by default with records that it can identify. So what that means is your records either need a primary key or a unique index for logical replication to be able to replicate updates and deletes. It's able to always replicate inserts, but to be able to do updates and deletes, it has to be able to tell what's changed. And so there's a command you can run. I'll share this. I don't believe this is in the tutorial, but there's a SQL command that you can run to effectively get all of the primary keys that are, or all the tables that are missing primary keys. So you want to make sure those primary keys are there. If you have tables that don't have primary keys, the other option is you can put logical replication in what's called full row mode, where it'll actually use all of the fields to determine the uniqueness. Now, there be dragons there, but this is one of the things we have to look for. So I'm going to go ahead and run that here just 1 second. Sorry, I didn't realize I disconnected from Postgres. Let me get back in there real quick. Okay, and then I'll just run this command really quick, and you'll see that there in this Spree database, there is actually 1 table that doesn't have any primary keys. So I'll share this SQL statement in the demo or in the demo tutorial GitHub afterwards. But if this was a production database, I would probably be going back and adding a primary key or a unique index across this to make sure that it gets replicated correctly. Cool. So with logical replication turned on and knowing that all of my tables have primary keys, so I'll be able to replicate the data, we can go ahead and get started with doing the actual database cutover. So again, there are about 8 steps that we're going to be walking through here. Stopping the application, taking the dump, creating the publication and subscription, restoring the snapshot, and then we'll also be adding some records as we kind of go through here. So I'm going to switch back over to the console, and I'm probably going to spend most of my time in the terminal here from here on out. So the first thing I'm going to do is I'm going to stop my application. So at this point in time, I'm in downtime mode. I've ceased any writes to the database. If you have background jobs, you'll need to pause those as well. You need to get the database to a point where it's effectively read-only. So I'm going to switch back over to my Postgres 12. And again, we are going to take a dump of the database, and then we're also going to create the replication slots and publications right now. So I'll just go ahead and run this command to take a PG dump. And then what I will also do is go back into Postgres. So I've taken a dump. I'm going to restore that to Postgres 15 here in a second. What I'm going to go ahead and do is create the publication and the replication slot for my subscriber, even though that doesn't exist. So this has to happen while this is the database is in read-only mode. If you're writing to the database now, what's going to happen is you're going to create distance between the dump and where replication thinks it is. So right now, no more writes have happened to this database. I have a dump that is this exact point in time, and replication is ready to start replicating from here on out. This is great for my target database. So at this point in time, I can start my application back up. That's the end of my downtime. So the downtime here is literally the time it takes to do a Postgres dump and then enable these publication slots, which are instantaneous. So what I would suggest before doing this in production is get a staging database with about the same amount of data in it and do that PG dump there to get an idea of what that downtime is going to look like so that you can plan that accordingly. So our application should be back up. I'm just going to switch over to Spree really quick and just make sure that it's up. It might take Spree a minute to kind of get back to where it is. And then I'm going to search for cat, make sure my cat hats are there. Cat hats, great. This is going to be a fantastic store. Okay, so let's go ahead and start restoring this data. So we've got the snapshot. It's sitting on this Postgres 12 instance. I'm going to use this Docker compose command to just copy this tarball locally. So you can see I copied 1.2 megs of data, and I'm going to push this up to my Postgres 15 instance. So this dump is sitting on my Postgres 15 instance. I haven't run the import process yet. Again, if I switch back to Spree, I can add a new product here. I can continue to have writes in this Postgres 12 instance at this point in time. So let's go ahead and add a cat fur vest. I don't know if this is a vest made of cat fur or if it is a vest for cats and it's a fur vest. We'll leave that up to the buyer team. But we went ahead and added that. So we have an additional record in Postgres 12 now. So if I select the count of my records here, see I got 119 in my Postgres 12 database. So that's great. I'm ready to perform this restore. So there's this point in time dump from earlier where I had about 117, 118 products in my database. I'm going to go ahead and restore that here. So at this point in time, I should be able to connect to the store database on Postgres 15. There we are. And if I run select Spree products here, I have 119 on 12 and I have 118 on Postgres 15. So you can see that my data is out of sync. I've got this point in time snapshot. I'm continuing to get writes on Postgres 12. I'll come back here. We're going to add another really, really great product. See this coming back. I think everybody's going to get one. Fanny packs. I don't know how to spell them. Fanny packs. There we go. And they're going to be $29.99. They're going to sell like hotcakes. This is getting written to this Postgres 12 database. If we switch back here, see 120 records, and my Postgres 15 is still out of whack. So what we're going to do now is we're going to create the actual subscription. This is going to tell Postgres 15 to connect to Postgres 12 and start doing communication between the wall sender and the wall subscriber to get this data in sync. So this command, if you're following along in the README, is very different if you're doing the quick data copy method where quick for you, not quick for the databases. If you do the data copy method, this command looks very different. This whole with statement is effectively missing at the end. You can see here is I've set a couple of features here. So I've created the subscription. I've given it connection details to Postgres 12. So my Postgres 15 instance, you can see here, now knows how to connect to my Postgres 12. The options that I have here are interesting. So first off, there's this slot name. So this coordinates with the slot name that I created over here. This is essentially my position as a subscriber. Create slot is false. It was already created on my Postgres 12 instance. So what's really cool about subscriptions is since it has access to this Postgres 12 instance, if you set create slot true and leave off the slot name, Postgres 15 will actually make the slot on 12 for you. And so that is another approach that you use in this like faster method of getting this done. That is the slower method in doing the restore because it's writing the logs across. So we're trying to turn off all this additional functionality because we want to be in control of the replication. You can see that I set copy data false. I've already copied the data here in this tarball. Also, I've got the subscription enabled set to false. So what that means is that the subscription exists, but it's paused. And so as soon as I unpause this, all the data is just going to start flowing through. So we'll unpause that here in just a minute. Now, for the sake of demo, I created this paused. If you were actually doing this in production, you could actually have this enabled and it would start pulling the data immediately. What I wanted to do is be able to add a few more records so we can see that the data isn't replicating and then turn it on and see the replication happen. I also want to illustrate how the wall LSN works between the two databases here. So what I want to do is grab this, run this command really quick over here. So there's a Postgres function called pg current wall LSN, which tells you the current log sequence number of the Postgres database. And you can also run on the subscriber side, pg stat subscription. You can see my subscription here. There is no messages received at this point in time. So these are the two commands you're going to use to determine if your application is in sync or not. You can do things like trying to do gold masters, selecting records from the database to make sure both records are there, doing aggregates, running queries and make sure the queries match, or you can just use this LSN, which pretty much guarantees that the data is consistent. So what I'm going to do is I'm going to add one more product to this database. Okie doke. Let's go ahead and add, we already got a shake weight. Let's add a rod of coolness with a K. So this is just a rod that you can carry around that makes you a bit cooler. So got a lot of really great products in this store that we want to make sure make it over to Postgres 15. Okay, so what we're going to do now is we can run this command one more time. You can see I got 121 products there. I've got 118 products in Postgres 15. And what I'm going to do is I'm going to simply enable this subscription. And so as soon as I run this, synchronization starts. So now if I select count from products, you can see I got 121 products. So now everything is replicating from Postgres 12 to 15. If I come back over here, we're going to add one more product. Let's add a octopus socks. These are very expensive. They're hard to get over the suckers, and there's 8 of them. Okie doke. So if I go back to Postgres 12, which is where my Spree application is writing to, I have 122 products. And you can see on Postgres 15, I also have 122 products. So now all this replication is happening. This is fantastic. So if I go back and I run those 2 queries again that show the LSNs, what I can do is I can see the current LSN on my primary, which is Postgres 12 still. And I can select my current subscription. Actually, let me go ahead and turn on extend display. You can see this LSN number here matches this LSN number here. This is great in demo. There's not a lot of data in here. These numbers get in sync pretty quickly, but when you are dealing with a production system, like these numbers don't tell you a lot when you look at them. This is what I was saying earlier, like the data structure behind this is actually pretty interesting, and there's some really good reads on it. We can share via email afterwards if anybody wants to check those out. But you can actually do some math on this to see how far apart your records are. So let me just go ahead and copy this LSN number really quick. So this isn't going to be super interesting because they're already in sync, but if you were in migrating a big production system, you can effectively run this command here. You can take, and this doesn't have to be on any Postgres. These numbers decode the same way either way. You can effectively cast the LSN number, do math on it, and then convert it to bytes. So you can see that my Postgres replica is 0 bytes behind. So if we go back to that idea of like doing copy data true, where it's going to copy everything, if you took the 2 LSNs, what you'd see is you'd see almost the entire size of the database as how many bytes behind you are. This is pretty much what you're going to use to determine when you are getting caught up in replication. If you see that this number is staying the same, that's where you'll probably have to go in and fine tune some of your Postgres config around wall size. What that effectively means is writes are happening to your primary so fast that the replica can't keep up. So if this number is staying the same or getting bigger, you need to fine tune the wall size and the chunk sizes and the window sizes there on the wall so that you can replicate data faster. Cool. So check that really quick. Okie doke. So we are in sync. At this point in time, we're ready to promote to 15. So this is where your next set of downtime begins. So the first downtime was when we took that PG dump, and we had to take that downtime because we needed to make sure that the replication slot and the dump were kind of in sync, as it were. So now what we're going to do is we're going to take the second downtime, and that is to do the cutover. So this is actually, while the first downtime can take a bit of time because it's bound to how long it takes PG dump to run, this downtime is actually pretty quick. It's going to be slower because I'm going to be talking on my way through it. But the first thing we'll do is we will stop our application. So I'll come over here, stop spree. And so I'm going to shut it down. I'm going to wait for any final writes that were being committed to get in sync. So I'll pretty much run these 2 commands again to make sure the LSNs are the same. Okay, you can see nobody wrote to this database while I was talking, so they are still the same. So they're in sync. So the downtime on this second part is effectively the amount of time it takes for the database to finally synchronize. So if you're getting to the point where you're seeing that LSN math command get to like 1 megabyte and you know you're pretty close, like that's probably when you're ready to do this downtime. You shut down, put your application in maintenance mode, you let that get down to 0 bytes, and you essentially promote the database, cut the credentials over, and you're done. So we see that these 2 commands are in sync. Promoting the database is really, really simple. So I'm going to run this one more time. You're effectively just dropping the subscription. So while this subscription is here, you're effectively acting as a replica. Now, there are other types of replicas in Postgres that are outside the scope of this conversation, but in this logical replication scenario, dropping this subscription is saying, I am no longer a replica to this other instance. I'm ready to start receiving my own rights. So as soon as we do this here, our databases are disconnected. So if I didn't shut down my spree application and new records are being written or people are adding things to cart, I've lost data now. So that's why it's really important to shut that down. And so now where we're at is we need to get these sequences synchronized. So I said earlier that logical replication does not copy sequence data. So if I run this command here, this is just a little command that looks at all the sequences from Postgres. Let me go ahead and turn on expand the display. And you can see here very subtly the numbers change. You can see the prices index has 200 is at 238, and the prices index over here is 234. So if I don't synchronize this data and I cut my spree application over to Postgres 15, the next time a price is added to the database, it's going to be record 235, which is going to conflict, which is good and bad. And if it conflicts, that means it doesn't happen. I know that there was a problem. If that record 235 happened to not exist, maybe somebody deleted it in the old database, now I would have a write, and now my next one's going to fail. And now I'm starting to get to corrupted data. So I want to make sure that I copy all of these values over. So again, these commands are all in the README that we posted on GitHub. So what I'm going to go ahead and do is run this first command. And I'm on my Postgres 15 instance, but you'll see here is I'm connecting over to my Postgres 12, right? I have access to it. And what I'm doing is I'm just running a simple SQL command to generate some SQL commands. So this is a little meta. and I'm going to dump it out to this sequences SQL file. So what we'll see when I peek this file is it will have commands to essentially update all the sequence numbers in my Postgres 15 database. So if you're following along, the password is pg12_password, which is super duper secure. If I look at the sequences file, do I have anything on here? I guess I can cat it. There we go. You can see it's just a series of set values. So it essentially selected all of the IDs from Postgres 12, rewrote some select statements here. And then what I'm going to do is I'm just going to pipe it back into my Postgres 15 instance. And the password here is pg15_password. You guessed it. Okie doke. So if I go back into my Postgres database now, and I run these sequence commands, you can see that all the values are now in sync. So this is great. So when I turn the Spree application back on and point it towards Postgres 15, I'm going to continue to get the right sequence numbers here. So again, these commands are all very fast to run if you're not walking through them. It's essentially just dropping that subscription, copying the sequence data, which is a very small table, and then loading it over here. So at this point in time, we are done with the migration. We just have to cut our application over now. So if we switch back over to this compose file, just so I can show you how this works, what you'll see in here is on line 42, there is a Postgres DSN that's pointing at our version 12. What I'm going to do locally is I'm just going to edit this file, switch it to 15, and bring Spree back up. And we should see that our cat hats, our shake weights, and all these really great products that people are dying to buy have been migrated to Postgres 15. So let me just edit my Docker file really quick, and then I will restart this. Okie dokie, my Docker file has been updated. And let me just go ahead and bring up Spree. There we go. Okay, so if I have my Docker compose file, you can see it's version 15 now is what it's using. I'm going to bring, that's not what I meant to copy and paste. I'm going to copy and paste this. And you can see Spree is coming back up. And what I'm going to do is just to make sure that Docker compose actually reloaded this, I'm just going to connect into Spree really quick and look at the environment variables to make sure that I'm connected to 15. Okay, database URL is Postgres 15, so we're good. So Spree has been cut over to 15. I'm going to pop into my Spree application really quick. Okay, fun times. Let's make sure Spree, let's check my logs really quick, see if Spree is doing something funny. It might just take a minute. It's a Rails app. Spree, it looks like it is up now. There we go. Okie doke. So I should be able to find shake weight. Oh yeah, there we go. My rod of coolness, definitely got that. Got cat hats and cat fur vests. So it looks like all my data is cut over. This is great. I've finished my Postgres 15 migration. So what I'm going to do here is I'm going to stop the Postgres 12. You'll see this shut down and kicked out of there. Postgres 15 is still running. So I've shut down that Postgres 12 instance. I've got Postgres 15 running. I've completed the migration. Now, there's one other thing you can do here, depending on what your tolerance is for any sort of issues. I didn't include it in the demo, but I just wanted to talk about it briefly, and that's back replication. So you've migrated to Postgres 15, you're doing writes there. Now, hopefully you've already tested your application on Postgres 15 before starting a migration to Postgres 15, but production happens. So you might find that there is an issue with Postgres 15, you got to roll back to Postgres 12. Well, this isn't great because now you have a different data. So all of these publish and subscribes that we've done, this actually happens with just data. So it's just essentially the inserts and updates that are happening. So it's kind of version independent, or it is version independent. So you can actually reverse the publish and subscribe now and go from 15 back to 12. So as you're writing records to 15, you're keeping your old database updated as well. So if anything happens with 15, you need to roll back to 12, you can just cut back over. So that is a thing to keep in mind. Now, so there are some complications there. If your application has already been updated to run or work with a Postgres 15 specific feature, and as a part of this migration, you also update your app to be using that feature, that's not going to be great for you if you need to roll back. So what I would actually suggest is when doing these major version upgrades, don't roll out new functionality using new features yet. Like let it sit for a few days to make sure that you're happy with running on that new version of the database, and then roll out new features that are using Postgres 15. So that's migrating upgrade Postgres with minimal downtime. Let me just show you one last thing here in MassDriver. So in MassDriver, MassDriver is bit cloud agnostic. You can run and manage infrastructure on AWS, GCP, and Azure. What I am running right now is the same Spree application on Kubernetes using Postgres 13, and I've got my Postgres 15 instance here. So if I wanted to do this same upgrade in MassDriver, I can use all of these SQL commands to create the subscriptions and publications between my databases. And then when I'm ready to cut over, I can simply grab the line, delete it, connect it to the new database, and redeploy my application. So I don't have to go through and change my DSNs or any of that stuff to my app. I can literally just move the line, hit deploy, and I've cut over to Postgres 15, given that I've done the publish and subscribe. So what you'll see in the platform is there's a lot of stuff that we do. So we manage infrastructure. We also configure alerting and monitoring and collect that alerting and monitoring data. We manage application secrets. You can see my Spree application has all my environment secrets here. We do something called dynamic configuration, which is effectively secrets injection directly into your containers. So you'll see here this Postgres or the Spree application doesn't have a database URL. It's actually getting it from this line. So the platform can really help teams that do not have a ton of operational expertise get running in the cloud with auditing, compliance, security all built in. If you look in our package manager, you'll see that almost every single bundle that you can deploy is SOC 2 HIPAA compliant, as well as passing NIST and CIS benchmarks for those clouds. All these modules are open source. So if you're not a user of MassDriver, but you want to have really great infrastructure that's secure and compliant by default, you can go to massdriver.cloud/marketplace, and you'll be able to see all of our bundles with links to the GitHub URLs of the source code, so you can run those Terraform and Helm modules. You'll also find that we published a lot of our guides on how we design and configure infrastructure. So you can learn a bit about how to run Aurora, see some of the run books on different services, as well as get a great Terraform module. So those are available to MassDriver users and non-users alike. So that concludes the webinar. I'd like to thank everybody for coming. If you're interested in talking more about MassDriver, learning more about it, we're going to be sending out a survey afterwards. Just go ahead and drop your email in that survey and we'll reach out to you. But if there's any questions, the team is in the Q&A channel, and we'll hang out for another couple of minutes to answer any questions there around Postgres or MassDriver. You can check us out at massdriver.cloud. Always happy to answer questions. Corey@massdriver.cloud. Happy to answer questions on Kubernetes and Postgres. Those are my two specialties. And if you want to schedule a demo, you can go to massdriver.cloud/contact.